So in this video we will be discussing about the way to recognize the value of Kc or way to determine the value of Kc. So to determine the value of Kc or to recognize the value of Kc, we have two methods, physical and chemical method. So the physical method we'll be discussing in this video. In physical method we have a method called spectroscopic method, and or we can also say spectrometric method. It is also known as spectrometric method. By this method, we determine the value of Kc on the basis of absorption of radiations. Radiations either can be UV rays, ultraviolet rays, visible rays, etc. So, spectroscopic method is a physical method in which we determine the value of Kc by the concentration or the absorption of radiation by reactant or either the product of the reaction. So in this method, the instrument which is used is spectrometer. Here spectrometer is used, and in this method either reactant or product absorb the radiation, either reactant or product absorb the reaction. This is the most important point, that either reactant or product, from both of these reactant and product, one will absorb the radiations. Here we have a reaction called N2O4 dinitrogen tetraoxide in the gaseous state, and this is the colorless gas, and this in the product is a reversible reaction. In the product we form dinitrogen oxide and 2NO2, and this gas is a reddish brown color. So it means the N2O2 is not absorbing the light or radiations, and but NO2, which is product, can absorb the light because it has a color. So we know that the substance or anything which absorb radiation, it is colorful, or we can say anything which is colorful, it means it absorbs light. So here we have a graph. So for the uh, journal absorption of light, we can say wavelength of light or absorption of wavelength, the same. So wavelength of light, we have determined the graph like 200 to 800, or we can say 760 something nanometer, and this shows the absorption, and this is the wavelength. So the graph starts from here and going like this. So this point, the point at which the wavelength or the absorption of any substance got maximum, is called the maximum uh, wavelength of that substance. So this is the point where uh, this is the point where maximum light has been absorbed by the substance. This can be either reactant or the product, but according to this reaction here, this means this is product. Okay, this is product. And in this graph here, the product has been started to form. In the starting, the time is zero in the starting. There's no product form. When time is equal to tq, when time becomes is equal to t equilibrium, means t eq means equilibrium. When time is equal to equilibrium time, the rate reaction, the absorbance become constant. Now this is the time or this is the point from which a substance cannot absorb more light or more radiations. Here we have a method how to determine or how to get the value of Kc by this technique or by this method. So here reaction N2O4 and 2NO2. We know that this is a colorless gas and this is a colorful gas. In the initial stage, we took a concentration of N2O2. Suppose a concentration of this reactant A mole. Okay, A mole, A mole. Okay, suppose a concentration of this reactant A mole, and here in the initial, the product is 0. The product is 0. When the time is equal to EQ, when the time is equal to EQ, the product is formed is 2x. Product is formed 2x. Here the product is formed which is 2x. Okay, and 2, the product is x, but there is a coefficient with this product 2, so here we have placed the 2x. And at that time when product has been formed, the product 2x or either x, here the reactant become a minus x. A minus x. So this is are the both concentration of the reactant and product after equilibrium. So now we know that the formula of concentration is mole per unit volume. So we will divide both these values by the V, here V and here V. We know that the formula of Kc is Kc, in Kc the product is written as a numerator and reactant is written as a denominator. So product upon reactant, here I have placed a square because of the coefficient 2x. So uh, 2x upon v whole square, 2x upon v whole square upon a minus x upon v. Here we have placed the value. Here we have placed the value of the product and reactant. When we further solve, 4x square upon v square divided by a minus x upon v. Now we'll cancel v by v will be cancelled by v, single v, and then the remaining equation becomes 4x square upon a minus x v. A minus x v, here was v square and the one v is remaining, one has been cancelled by this. So 4x square upon a minus x v. So this is a equation used to find the value of Kc of this reaction. Suppose if the concentration of x is 2 and a is 5, a is x is 10 and a is 5. So by this you can put the value of both ax, and there will be also value of the v given. So when you will put the value of x and a, x means the concentration of reactant product and a is a concentration of reactant. So by putting these values you can determine the value of Kc. So this was the complete physical method, or the we can say spectroscopic method, by which you can determine the value of Kc. So again I'm repeating. So spectroscopic method is a method used to determine the value of Kc on the basis of absorption of light. Either reactant is absorbing or the product is absorbing. But the reaction which we have discussed, in this reaction product is colorful, which means product can absorb the light, reactant can't absorb the light and it is colorless. We've discussed two graphs. One graph is of general the peak point of the absorption peak point, and second we have discussed about the concentration of the product. And here this is we got a formula how to determine the value of Kc by this technique, and by this equation you can put the values and you can get the value of Kc.